Chapter 9 is on quadratic functions, and in Section 9.1 we're looking at graphing quadratic functions in vertex form. Before we can begin, we need to get a graph of the basic parabola so we know what we're looking at here when we talk about quadratic graphs. So if I have x squared, I'm going to fill in this table right here for the values of x, and then we're going to graph this. So fill in your table and graph all of the ordered pairs, connect them. We know that's this basic parabolic shape. And a couple of things to notice are that the parabola x squared has a vertex at 0, 0. Then it has points 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. We're going to be comparing this graph to a few other graphs in the next couple of examples. First, I'm looking at functions of the form f of x equals a times x squared. So there are three graphs drawn here. One of them is x squared, one of them is 2x, one of them is 4x, and I want to identify each of them. So I want to know what f of x equals x squared looks like. I know it has points 0, 0, 1, 1, 2, 4, 3, 9, etc. So this one must be f of x. Now g of x is 2 times x squared, so the y values are going to be 2 times those of x squared. So notice 3, 9, 9 times 2 is 18, 3, 18. Or 2, 4, 2 times 4 is 8, so this is twice the y value, so this one must be our g of x function. The h of x function is going to have y values 4 times f of x's values. So f of x has a value of 2, 4. 4 times 4 is 16, so I can see 216. And 1, 1. 1 times 4 is 4, so this one is the function h of x. Okay. Now, the larger the size of a, if a is 1x squared or 2x squared or 4x squared, the larger the value of a, the narrower the parabola looks. So the narrower the parabola. Let's look at the next page. 3 more graphs here. We want to identify x squared, 1/2 x squared, and 1/5 x squared. X squared is going to have 1, 1, 2, 4, 3, 9, and 4, 16. So this one must be f of x. G of x is going to have y values that are 1/2 of those of f of x. So if g of x has 4, 16, half of that is 8. This one must be g of x. And h of x has values 1/5 those of x squared. So if I have 25, if I divide that by 5, it gives me 5. So this one must be h of x. Okay, so f of x, 1/2 and 1/5. So the smaller the size of a, the wider the parabola looks. All right, in the next example, the coefficients are all negative. So when they're negative, they're going to be reflections of each other across the x-axis. So I know that f of x equals x squared has the point 0, 0 and 1, 1. So negative x squared will have 1, negative 1, and 2, negative 4, and 3, negative 9. So this one in the center must be f of x. Negative 1/2 x squared, we have half those values. So it'll have 2, 2, and 4, 8. So this one on the outside must be g of x. H of x will have twice the values. So this one will have, instead of 2, negative 4, it'll have 2, negative 8. And instead of 3, negative 9, 3, negative 18. So this one will be h of x. Okay. So if the absolute value of a is greater than 1, the large value, where it's 2, that's greater than 1, it's narrower than the one that has absolute value less than 1. This is the wide one. So the greater the value is, the narrower the graph is. Summary here. If a is positive, the parabola opens up. If a is negative, the parabola opens down. If a is a large number, the parabola is narrow. And if a is a small number, i.e. near 0, the parabola is wide. Let's look at some more modifications. What if we have x squared and we add k to it? So x squared is the graph that has a vertex at 0, 0, then 1, 1. If you have x squared plus 5, you're going to take your 0, 0 and go up 5. So you have f of x on the outside here, g of x on the inside, and if you go up 8, you're going to have h of x on top here. Okay. So How does k affect the graph? It's a vertical shift. All right, so for our k larger than 0 right here, we're going to be going up. Let's look at some more examples. What if you have x squared, this one in the center, compared with x minus 4, go down 4, this one in the middle, and go down 9, this will be h of x. If you have a k value that's negative, how is it going to affect the graph? It's a vertical shift, this time down. Summary here. K greater than 0, the parabola is shifted up. K less than 0, the parabola is shifted down. Now, the k component is shifting the y-coordinate of the vertex. So the y-coordinate of the vertex is k. Next page. If I'm looking at a function of the form f of x equals x minus h squared, what happens there? F of x is the graph that has center at the origin. If you have g of x equals x minus 2, shifting 2, this one must be g of x, and x minus 5, shifting 5, this one must be h of x. Okay, so the value of h. Notice the value of h is the value that comes after the negative. The value that comes after the negative is 2 right here. The value that comes after the negative is 5 right here. It's going to be a horizontal shift, and if h is larger than 0, we're going to go to the right. Last, we have our f of x. F of x equals x squared. It has a center at 0, 0. If you have x plus 3, that's the same as saying x minus negative 3. And if you have x plus 6, that's the same as saying x minus negative 6. So you have minus 3, you're shifting to the left 3, and minus negative 6, you're shifting to the left 6. So this is going to be another horizontal shift. And x minus negative 3, this h value is negative 3. So when your h values are less than 0, you're shifting to the left. H greater than 0, parabola shifts to the right. H less than 0, the parabola shifts to the left. The x-coordinate of the vertex is h. If the x-coordinate of the vertex is h and the y-coordinate of the vertex is k, the vertex must be hk. Alright, so look at the vertex of this first parabola. It's x minus 7, so the vertex is going to be at 7, comma, negative 5. Remember that the negative is part of the formula here, so I'm looking at 7 and negative 5 for the x and y coordinates of the vertex. Now the graph opening up or down is going to be dependent on a, and so a is positive, it's going to be opening up. The graph shifting up or down is going to be dependent on k. K is negative, so it's going to be shifted down. Left or right is going to depend on h. H is positive, so it's shifted to the right. Let's look at the next one. The vertex, this is negative, negative 1, so it's going to be negative 1, negative 2. A is negative, so it's down. K is negative, so that's down. And H is negative, so that's left. Okay, next we have something that has a vertex. This is negative, negative, so it's going to be negative 4, comma, there's no k value, the k value is 0. Opens up, our A is positive. There's no k value again, so there's no shift on this one. And then left, right, our h value is negative, so this is to the left. And the last one here, the vertex is going to be at, we're going to have 0, comma 6. There is no h value. The h value is 0, and the k value is 6. It's going to open down because the A is negative. H is positive, so it's going to be shifted up. And there won't be any left or right shift because there's no h value. Which of these graphs is narrowest? Remember that narrow depends on A, and I want to have the largest absolute value of A. So the largest absolute value of A is going to be on G. 4 is the largest value there. Widest, I want the smallest value, that's absolute value. And since 1/4, 0.25 is smallest, it's smaller than 0.3, k of x is going to be the widest. Which graphs have two intercepts? So a graph is going to have two intercepts if it faces down but was shifted up. So if it opens down and shifted up, or if it opens up but shifts down. So we have opens up, shifts down, and opens down, shift up. If A and K give you a different direction, one's up, one's down, that's when we have two x-intercepts. So f of x and k of x will have two intercepts. Notice that if you open down but shift down, you're not going to have any intercepts. It's got to be opposite. Opens up, shift up. Doesn't have any intercepts either, but opens down, shifts up, and opens up, shift down. Both have two intercepts. All right, in example 2, we want a graph. And we're going to start by finding the vertex and putting that in the middle of our table here. So the vertex is -2, -4. Now, I choose the vertex first because that allows me to pick smart values for x. I want to pick x values that are on either side of my vertex. So I'm going to go with -3, -4 in the smaller direction, and -1, 0 in the larger direction. Now let's find the y coordinates by plugging them in. -4 plus 2 is -2 squared is 4 times -3 is -12 minus 4 is -16. -3 plus 2 is -1 squared is 1 times -3 is -3 minus 4 is -7. -1 plus 2 is 1 squared is 1 times -3 is -3 minus 4 is -7. I'm going to put 0 in here. 0 plus 2 is 2 squared is 4 times -3 is -12 minus 4 is -16. Okay, so we know that if we have the vertex, it's nice to pick numbers on either side of it because there's some symmetry here in our ordered values. And it's going to make it so that I don't pick values going to be way off the grid. All right, so let's graph these. -4, -16, -3, -7, -2, -4, -1, -7, and 0, -16. I might also find the value at 5 just to see what's on the graph here. So let's plug in -5 and 1. So I plug in 1, so that becomes 1 plus 2 is 3, squared is 9, times -3 is -27, minus 4 is -31. So at 1, I'll be at -31, and at -5, by symmetry, I'll be at -31. So let's graph. So as you can see, this is a downward facing parabola that has been shifted down, so it doesn't have any x-intercepts, and it has a vertex at -2, -4. What's the domain? The domain is the set of all x values that you're allowed to plug into the function. Since this function continues downward forever, it's also going to widen out in both directions forever, so the domain is the interval from -infinity to infinity. It's all real numbers. The range. The range is the height, the y values. We know we're going to get all the negative values, but there is a limit to the top value right here. It's not going to go any higher than -4. So the range is all the negatives up until -4. Then you got to stop. So we're going to have all the negatives until -4, including -4, so we've got a square bracket there. Let's go to the next one. Okay, we've got a couple functions here. We want to determine the signs of A, H, and K. This one opens up, so A is positive. It's been shifted to the right, so H is positive, and it's been shifted up, so K is positive. The next one also opens up. So opens up is A. This one opens up. H is 0 since it hasn't shifted left or right at all, and K is positive since it's been shifted up. In part C, this graph opens down, so A is negative. It's been shifted to the right, so H is positive, and down, so K is negative. Part D, A is negative because it opens down. H is negative because it's been shifted to the left, and K is 0 since it has not been moved up or down from the x-axis. Which equation has the largest A value? I'm looking for the narrowest graph. The narrowest graph looks like part D right here. And the smallest a is going to be the widest graph. So the widest graph is on part C. That's the end for the section.